So hey guys, welcome back to the channel. This is your physics buddy, and today we are came up with another important session on graphing motion. This problem session is specifically based on solving real life application based questions, which will definitely help you to excel in school as well as in end sem exam. So make sure you stick to the channel, subscribe for upcoming videos, and this is going to be another very powerful session for you all. Just start writing.
Alright, let's try to sketch it. So it's a position time graph. It is question 7 from this worksheet A, graphing concept. So the first floor as a reference point. Now just try to understand this thing. So I'm not drawing a lift, but I'm drawing a reference point. So this is supposed to be the first floor, I'll assume. And below the first floor, it should be ground floor. And then it should be basement. Above it should be second floor. And above it should be third floor. So initially, the lift was supposed to be at first floor. Let me assume this is the lift. So on the
But it
first
says
floor,
basement is below the first floor
all
in the
right.
problem
So
itself.
technically, it should be below the ground floor, but yeah, as the question says, let's move accordingly. So the question says that using the first floor as the reference point, up is positive starting at time t is equals to 0. So at this particular position, time is supposed to be 0. It stays. The elevator waits at the first floor for 30 seconds. So from 0 to 30 seconds, it stays at this particular point only, I can say, first floor. Then it rises to the third floor in 20 seconds. So I can say the lift reaches the third floor in next 20 seconds. So time must be here like 50 seconds. Now at the third floor again, it waits for 20 seconds. It is going to be final time. Then it start moving from third floor. It is going to be 70 seconds because it has waited for 20 seconds. 20 seconds waiting time it's given. After third floor, it came to the basement in 40 seconds. So this lift goes to the basement, and here it has took almost 40 seconds. So I can say that the 70 seconds must have become 110 seconds here. That's it. So now it is quite simple. Try to observe it. We'll assume that the distance between each floor is same. Let me just take it as x. So let me just mark the graph. It has x. This is t, where x is supposed to be the displacement, t is supposed to be the time. So the graph should start from 0 and it must goes to the third floor. So let me just mark the time also. It should be in the 20 seconds interval. That would be better. Always remember, whenever you are drawing such motion or representing motion of any particular thing, the time stamp should be very particular. Whatever time you are taking, the time should be equally taken in the graph. So from 0 to 30 seconds, it remains at first floor. So basically, it didn't move for the first 30 seconds. It should be a straight line. Till what point? Till 30 seconds. Then for the next 20 seconds, it moved to the third floor. So at 50 seconds, I can say if this is x, this will be 2x. So this would be the point. This would be the point where the lift should be. Lift is supposed to be at 50 seconds. So graph must go like that. Remember, a straight line from 0 to 30 seconds, then from 30 to 50 seconds, it should be a constant slope because it is increasing, and as lift is always moving with constant speed. Now again it waits for 20 seconds. So from 50 to 70 seconds, again it is going to be a straight line parallel to time axis because it is at rest. Now till 70 seconds, after 70 seconds, it moved for 40 seconds going to the basement. So if it is going to the basement, it should be negative x. That is what we have to assume. It should be positive x upward, it should be negative x. So at this particular time, 220 seconds, it should be 20. So at this particular time, now observe this particular thing. So at 1/10 second, the graph should go like that. So this is how the motion of moving elevator looks like over a period of time. We just have to observe each and everything here. Also, you can mark 2x and negative x. where you will mention that x is supposed to be the distance between the two floors. And as we are representing the position time graph, so when it is going down, it is going to be negative of x from the initial position. So
Mhm.
that's why we have written negative x. So this is going to be the distance between the two floors. That is how we are supposed to draw the graph.
Okay.
All right, tell me the next question.
Mm, third, 13.
Okay. So the 13th question, it
Mm.
says a person drives a car at a constant 25 meters per second for 10 minutes. Now, what is 25 meters per second positive? Positive means it is going in the forward direction. So let me just
Mhm.
assume that initially my car was supposed to be at this particular point. Oh, and it was moving constantly at 25 meters per second for next 10 minutes. All right. Then the car runs out of gas. So they carry an empty gas can and walk at 1.5 meters per second for 20 minutes to the nearest gas station. All right. So I assume that the car must reach at certain point. Let me mark this point as A. And at this point, it stops. So its velocity must have become zero at this point. But that person just came out of the car and start walking in this direction only as it is positive. So it is 1.5 meters per second. As the velocity is positive, so the person is again moving in the forward direction, not in the backward direction. Positive and negative sign actually help us to find out that in which direction a particular object or a person is moving. It takes 10
Yeah.
minutes to fill the can, during which they stand still. So let me just assume that at point B, uh, there's a gas station, and at this gas station, the person stands for 10 minutes till the time it takes to fill the gas. So let us try to understand that how much time it took. From O to A, it took 10 minutes. From A to B, it took 20 minutes. Then it stands still at this point. So waiting time it's supposed to be 10 minutes again. Now it's saying then the driver walks back to the car at a slower rate, negative 1.5. Again, negative means what? Negative means it is coming back, but the velocity now has decreased. So I will assume that it is going with point 1.2 meters per second rate. The car is then driven back home at negative 25 meters per second. What happens when the person reaches at point A where the car was standing? It start going back to its initial point at negative 25. So it is going to be 25 meters per second again. So on the graph paper, or very accurately on binder paper, draw a velocity time graph for the driver. Using seconds on the time unit, the last two parts are very tricky as you will have to calculate the distance from the first two parts. We have to draw the velocity time graph. Okay. Then use those to find out the time for the last two parts. Convert, remember to convert it to seconds. Now draw the matching position time graph for this strip. All right. So basically here we have to draw two graphs. One is velocity time graph, other is going to be speed time graph. And the distance and the graph should be in seconds. Time should be in seconds. Remember this. So again, let us consider the whole thing from the seconds point of view. So at O point, time is supposed to be 0 seconds. At A points, time must be 60 seconds, as it has traveled for 10 minutes only, so it is going to be 60 seconds, not 60, 600 seconds. At point B, time is supposed to be now 600 plus 1200, so it is going to be 1800 seconds, almost half an hour from the starting point. Now it stays there for next 10 more minutes. So from 1800 seconds, time has now changed to 2400 seconds. So at this particular point, the time changes to 2400 seconds. Now it is coming back at a slower rate. Now we don't know how much time it took, or is it given? No, we don't have any time that how much time it took. So we have to find out the time for how much time it has moved from point B to point A, or you can say from gas station to his car. So in order to find out time, we need to first of all have the distance between point A and point B. So how can we find the distance? Using the simple formula, speed is equals to distance upon time. So we'll write it this way. To find distance between his car and gas station, we have the information. It is moving with speed 1.5 meters per second, and the time for which it has moved, it is almost 20 minutes. So we can say it has moved for 1200 seconds. So as we know, speed is nothing but distance upon time. So distance is going to be speed into time. Speed is 1.5, time is 1200 seconds. So I can say it is going to be 1800 meters. So the distance between the gas station and the point where his car gets out of gas is 1800 meters apart. Now,
Mm-hmm.
we understood that the distance between point A and point B is 1800 meters. Now, we'll try to find out that how much time that person will took to come back to its car from the gas station. So again, we'll do the same. We'll apply the same formula, but the velocity will be changed. So to find time person took to come back to its car, we have its speed as 1.2 meters per second. We know the distance this time now, 1800 meters. So again, we know speed is nothing but distance upon time. So time is going to be distance upon speed, which is supposed to be 1800 over 1.2. So we'll solve it. It is approximately, I can say 1500. Almost 1500 seconds it took for him to come back to the car. Now
Mm-hmm.
we got the timestamp. So from 2400 seconds, it took another 1500 seconds to come back to its initial point, that is, to come back to its car again. So now the time at this particular point must have become 2400 plus 1500, which is going to be 3900 seconds. Now, again, the person drives with 25 meters per second. So, again, as initially it took 10 minutes, so finally also it took 10 minutes because it has traveled with the same speed. So 10 minutes means 600 seconds. So we'll add 600 again. So initially it reaches to its initial position or its home at t is equals to 4500 seconds. Now this is the all information that we needed to plot the graph. Let's start with velocity time graph. In all the cases, velocity time graph is going to be a straight line as the velocity is constant. It is not something which is changing as the particle doesn't have any acceleration, car doesn't have any acceleration. Remember this. So let us try to draw this. Although we have to consider the sign, so negative positive will be there. So this is going to be a little tedious task because I'm just considering these points as velocity. So it is 25 meters per second. It is negative 25 meters per second. It is 1.5 meters per second. It is negative 1.2 meters per second. Again, remember the distance between these 2 points should be huge, as initially it was moving in a car and then finally it was moving by walk. Now the time is important. So how we are supposed to represent the time, that is again the case. It starts from 0 till 600 seconds. So let me just, so total time is 4500 seconds. So let me just consider 5 instance, assuming 1000 each. So 1000, it's a 5000 almost. Again, the graph should be very accurate as it already mentioned. So make sure you mark the points very accurately. So initially for 600 seconds, the car was supposed to be moving with 25 meters per second. So let me just mark this point as 600 seconds. It should be before 1000. So this is 600 seconds. Now the speed reduced to 1.5 meters per second. For how much time? For next 1200 seconds. So I can say from this particular point to this 1200 seconds, 1800, like till this point, this is going to be the speed and this is how you are supposed to represent it. For next 10 minutes, that is again for 600 seconds, it waited. So it's standing still. So its velocity is going to be 0. So graph should be overlapping this particular line.
Mm-hmm.
Then it is coming back, but at a slower rate. That is negative 1.2 meters per second, and it traveled for 1500 seconds. So from this particular point, 1500 seconds, so 20, that is 3900. So it is supposed to be till this. So I can say from this point to again a straight line in the negative direction, we'll mark it as like this. Then again, it is coming back at the same rate. So it is going to be negative 25. So if you're drawing it on a white paper, you can use this particular method. Now it has traveled for 4500 seconds only. Last line is representing 5000, but we have to 45. So somewhat in the middle, it should be there. So this is going to be the last 10 minutes. Now always make sure that if you're drawing it on a white paper, you mention these points. So this time is 600. This time is 1800. This time is 2400. This time is 3900. And this is going to be 4500 seconds. So this is how you're supposed to draw a velocity time graph. Does this make sense?
Yeah.
Now we have to draw the position time graph. That is a little tricky one. Let's see how we can draw it. So again, the time instance I'm taking as same of 1000 seconds per interval. Like that. So for each time, we have to find out the distance as well, like the position. Let us do that also in this diagram only. So initially when it was there, x is supposed to be 0. In 10 minutes, it has reached point A, moving at 25 meters per second. So how much distance it has covered? Let us try to find out. So x1 is going to be speed into time. Speed is 25. Time it took is 600 seconds. That is going to be 600, which is approximately, I can say 15000, 15,000 meters, almost 15 kilometers. So we have to take 15,000 meters only. Then from point A, so I can say that x1 is going to be 15,000 meters. Now point B, it has covered 1800 more meters. So 15,000 plus 1800, the position at this point is going to be 16,800 meters. Then it moved back to 15,000 meters, then moved back to the 0. This is how it has moved. It went like that and then came back to its initial position like that. So we got the upper limit. The final distance it has moved is approximately 16,800. Now, in this particular graph, how we are supposed to represent the distance? That is another important thing. You can use whatever scale you want, but me, I'm taking 5,000 meters scale here. Let me just redraw this line. So 5,000, another 5,000, that is 10,000, then 15,000, negative 5,000, negative 10,000, negative 15,000. Although it will not go in this particular quadrant. It will stays at the top only, in the first quadrant only it will stays. All right. Now we got the time and the position both. So x0, t0, particle was at point O. So this was origin. I can mark 0, 0 here. This is supposed to be my time axis and this is supposed to be my position axis. So at point A, the time is supposed to be 6,000 and displacement is supposed to be 15,000. So see, time is supposed to be 6,000, 600 seconds. And this is 10,000 sort of thing. So this is my 6,000 point, I assume. And this is my 15,000 point. So graph is going to be again a straight line. Remember this thing. Particle was moving with a constant velocity. So velocity time graph will be a straight line parallel to time axis. Whereas displacement time graph for this particular question will look like that. It should be a straight line. Remember this. Kind of difficult to draw it here, but yeah, you can draw it easily on the graph paper. And always use scale and pencil to draw this. It should be very accurate. Almost I got. So this is the 6,000 seconds point, and this is 15,000 meters. Now, next position. It says from point A to point B, it has moved another 1800 meters. So the position at point B is 16,800. And the time is going to be what? 1800 seconds. So from 600 seconds to 1800 seconds. So this was 6. So let me mark it as 18. 1800 seconds it is. It has moved for 16,800. Now this is a little difficult to plot. But on the graph paper you can do it. It is not going to be that difficult. But you need to understand that how we are drawing it. So it is going to be again a straight line joining these two ends. So I am drawing this dotted line so that I can draw it easily like that. So this is the second position as per our graph. This is point O, this is point A, this is point B. Now it took 10 minutes for it to recharge and refill, I can say. So 10 minutes means it becomes 2400 seconds now. So for the next 10 minutes, it stays same. It should be a parallel line parallel to time axis. So it is going to be a straight line like that. So this is the point B itself because it has waited. Now what happens here is it starts moving back. So it has covered again 1800 meters in 1500 seconds. So 2400 plus 1500, which is supposed to be 39. So this is the point 3900 seconds. I'll extend this line a little further till 3900 seconds. Now again, you have to draw a straight line like that. Moving back at 25 meters per second at 4500. So again, you can join a straight line like that. So this is representing the position time graph for this particular case. Make sure the points are joined perfectly using scale. You cannot join it freehand. You have to make sure that.
Okay.
Is it clear? Yeah. So
Yeah.
this is the displacement time graph, and you can see the position as the particle has came back to his house. So this is on the same line. It hasn't
Right.
moved up. It came back because of the position. Try to understand the situation given in the graph. Whatever things that we need to find, we have to find them first, and then we can do the changes. Clear?
Yeah.
All right. Tell me next one, which you want to discuss.
It's 14.
All right. So question 14 says figure 319 at right shows a velocity time graph for an automobile on a test track. Based on the car's velocity changes with time, what does it look it is doing? So it's quite difficult to draw it here, but I'll try to make you explain this. So from so time axis is given as 0, 5, 10. Let me just take it till here only. Whereas this is the velocity, it is 5, 10, 15, 20, something like that. So as you can see, the velocity at the end of 2.5 seconds is supposed to be almost 7.5, right?
Yeah.
And the graph goes like that. A smaller curve, but yeah, it's a curve. So just try to remember when we were studying the graphs, what we saw, which type of graph it is this. Is it
Mm,
so? Suppose if you have given a velocity time graph and the velocity is going like that, like there's a curve. So what this curve actually represents, that is what this is what we have to understand. So as you can see, at certain point, it says that the velocity is going to be constant. Initially, it increased at a good rate, but later on, its value becomes kind of constant. So it is actually representing that the particle was initially accelerating, and later on that acceleration changes, reduced. So this is actually representing variable acceleration case. It is a variable acceleration case. And this, what variable acceleration it is? Acceleration is supposed to be maximum in the beginning, and at the final, acceleration is supposed to be 0. So initially it has some value, but finally it becomes 0. This is what it explains. Similarly, this is what the graph is also representing, this first portion. Later on also, same thing happens. It started accelerating, then becomes 0. Then again, it started accelerating, and the velocity reaches almost about 20 as per the graph. Then, not 20, it reaches about 10 or 12, you can say. So you just have to check it once. Don't look at the values, just try to understand. So from 0 to 7.5 meters per second, its velocity increases in such a way that initially at t is equals to 0, acceleration was maximum, then it becomes 0. So here it is a case of variable acceleration. So in the first section, it has some variable acceleration. So the question says which situation it is going to represent. So as you can see, it is a velocity time graph for an automobile on a test track. So what is the test track? Test track is basically you are going to test the speed of the vehicle. And when you are testing the speed of the vehicle, what the person is supposed to do, the person must be accelerating and then just uh, pull it leg out of that accelerator. Then again it push it. Then again it pushes the accelerator. So again speed increases. Then again it just push it away. Then again it push it back. So it is kind of that situation. So in this case, you don't have to actually you can say you don't have to actually understand like find something, but only you have to do is you have to just understand that what is going on in this particular graph. So
Okay.
whoever that person is drawing, whoever person is driving that car, he must be pushing that accelerator for certain time, like as in say, as the question says, for first 2.5 seconds it has pushed the accelerator, then again it brought to a rest, like again it has just went uh, so I would say that the person initially just pushed the accelerator, then just put it like away from it. So that whatever velocity it reach, it stays at it. Then again, it does the same. So again, velocity increases. So this is the graph which is actually representing the gear change. So what you see when you are driving a vehicle, in order to push or in order to switch the gear, you just have to accelerate some time, and then
Yeah.
that gear does the job. So from this particular graph, I can say the person has shifted from first gear to second gear in 5 seconds almost, then second to third, and third to fourth. And at 4 seconds, its velocity becomes 30 meters per second. So this is a graph which is actually representing the person is switching the gears by increasing its velocity. That's it. Does this make sense?
Yeah.
All right. Tell me the next one.
Okay. So sometimes you have to like actually doing calculations using it, kind of like understand or visualize
Yeah,
the
that
example
what
in which.
exactly is being asked in the question. So this is
Okay.
not a graph in which you have to actually find something, but you have to think about it, that what exactly is going on. And in order to actually think and visualize all those things, you need to first of all understand that which type of graph it is. So it's a velocity
Yeah.
time graph. You know what kind of velocity time graph it is. It is a variable acceleration case, and in this, you can just visualize it that initially acceleration is maximum and then it becomes automatically 0. Then again, the process repeats. So that must be a case of person switching gears. And this is what we does when we actually switch the gears, right?
Next problem is 15.
So 15 says a walker and a runner leave your front door at the same time. They move in the same direction but at different constant velocities. Obviously, there's a walker and there's a runner. Describe the position time graph of it each. Now, this is pretty easy.
Yeah.
You have to just find out the position time graph. So, walker has lesser speed, runner has more speed, but a constant velocity. And we know constant velocity if we want to represent using displacement time graph, that is xt graph, then it is supposed to be a straight line making an angle. So what you need to understand here is that the angle it will make, it is going to be different. For example, suppose a person at this home at this point A has to reach school. One walks, other runs. Who is supposed to reach the point B faster?
Mm, the runner.
Exactly. Who will take more time?
Walker.
Whosoever is walking, right? So
Yeah,
this
Walker.
X is representing the point B, I can say, and this particular points are representing the time. So I can assume the runner reaches quickly. So if it has reached quickly, it must have higher velocity, and higher
Right.
velocity is represented by more angle. So it is
Right.
going to be more. Whereas it is going to be lesser angle. So here you will mention that theta 1 is supposed to be greater than theta 2, as theta 1 will give us the slope for who? For runner. And theta 2 will
Mm.
give us the slope for walker. So the slope of displacement time graph gives us what? Velocity. So this is what we already know. So velocity of runner should be greater than velocity of walker, which is represented by this particular graph. That's it. Tell me the next one.
16.
What quantity is represented by area under velocity time graph? We understood this very well. Now you should answer this. When we are finding area under velocity time graph, what are we supposed to get?
Um, area under.
Suppose this is the constant velocity. I'm just assuming a constant velocity graph, and you have to find the area of this. So when we actually find out area, what we does? We simply multiply the x quantity with the y quantity. So velocity into time. What we will get when we multiply velocity into time? We'll get displacement. That's it.
Displacement.
This is our answer.
Oh, got it.
Have you tried this worksheet yet?
No.
Okay, you should do it.
Yeah.
All
I'll do the rest. Oh my God.
yeah,
The test
just
is on
let me.
Tuesday.
This Tuesday.
Yeah.
All right then, as it is Sunday at your time zone. So if you have any problem, you can just ask me. We can do class tomorrow as well, or around same time.
All right.
Yeah,
Sure.
but make sure that you try all those questions. And if you have any difficulty in any of these questions, just let me know.
Okay.
Although we can discuss some more questions. Tell me which questions should we do. Let me just see and tell me which questions should we do now.
22 maybe.
Yeah, we can do it. So describe in words as accurately as possible the velocity between 0 to 20 seconds of a toy train shown in figure 4.6 at right. So we have to describe this graph in words accurately. Let's see what the graph says. So it is still 40 seconds. So let us draw the timestamp 10, 20, 30, 40. And the velocity is supposed to be 2, 4, 6, 8, 10, 12. So the first line, 0 to 5 seconds. The particle's velocity or the toy train velocity increases sharply. So within 5 seconds, its velocity becomes 10 meters per second. Now just tell me if this part is representing that its velocity is increasing from 0 to 10 in 5 meters per second. What can you say about the motion of the toy train?
It's accelerating.
It's accelerating. So we will write it that we'll write that thing only. So we will say initially the train was at rest at t is equals to 0 seconds, but it starts accelerating at a constant rate. And how can we find that constant rate? By simply calculating the slope.
Right.
We know the slope of VT graph will give us acceleration. So the slope of this particular graph is equals to 10 by 5, that is 2 meters per second square. This is the acceleration. So we'll say initially the train was at rest at t is equals to 0 seconds, but it starts accelerating at a constant rate of 2 meters per second for next 5 seconds. So this is what this initial line says. Now it's continuously moving with 10 meters per second for next 10 seconds. We'll write the same. For next 10 seconds,
Wait, why is the rate squared?
just look at the graph. It goes like that. Then the velocity remains 10 for next 10 seconds. So
I understand that, but why is it 2 meters per second squared?
because it's an acceleration.
Oh, right. Acceleration is
Velocity is
always.
what? Velocity is meters per second, time is seconds. So
Right.
meters per second divided by second will give us meters per second square. And that is the unit of acceleration.
Right.
Yeah. So we will simply say that the for next 10 seconds, it continues with constant velocity of 10 meters per second. Now, in the next 5 seconds, its velocity changes to 4. So if its velocity changes to 4 in next 5 seconds, again, what can you say about this?
So it's decelerating.
Exactly. It must be decelerating at a constant rate once again. And we will say that the acceleration in this part is going to be 4 minus 10 by 5. That is 6 by 5, that too of negative meters per second square. So we will say from this particular point, now for next 5 seconds, it decelerates at a constant rate of 6 by 5 meters per second, or you can also write 1.2 meters per second. If you're writing it decelerates, don't add negative here. If you're writing for next 5 seconds, it accelerate at negative 1.5. So if you're writing accelerate, then you need to write negative sign here. So
Got it.
remember these two things. If you're writing decelerate, don't add any sign to it. If you're writing accelerate, then you have to add the sign as well. So we'll simply say that it is decelerating at a constant rate of 6 by 5 meters per second. For next 5 seconds, we have written it. Now, the next it says that from 20 to 40 seconds, its velocity reduce like that. Now, if velocity is reducing like that, what does it mean?
But it does say constant. It doesn't say constant there.
Exactly. So this is the difference between this line and this line. So
Hmm.
we will mention here that afterwards, the toy train do decelerate, but not at a constant rate. It reduces its speed to 0 in next 20 seconds. That's it. This is how you're supposed to answer this question, because the question is simply saying that describe how the changes in the graph takes place, or how the change in the position of a particular toy trains takes place. So this is how you have to describe this particular velocity time graph in words, and this is as accurate as possible by mentioning all the changes, like 2 meters per second square for next 5 seconds, 10 meters per second velocity, constant velocity for next 10 seconds, 6 by 5 meters per second at a constant acceleration rate. So this is how you're supposed to answer. Always remember, this is like the key conditions. So you're supposed to have test on Tuesday.
Yeah.
All right then. And tomorrow you are supposed to go to school, right?
Yeah. Well, we'll probably have a review that day.
Okay. And what is exactly going on in the class as of now?
Yeah. So it's Unit 3, and it's called graphic motion. So it's basically this. So
So
one more
it isn't
question.
done.
Yeah.
It isn't
Uh,
done yet in the class.
no, it's gonna be. Well, I guess it's done already because test is tomorrow or Tuesday. So yeah,
Oh,
almost done.
so tomorrow there will be a revision sort of thing, and day after tomorrow it will be a test.
Yes.
Yeah, you were saying something.
Yeah. So when it mentions area under the curve, does that simply mean displacement?
See, I just make you explain this thing when we're talking about area and slope.
Yeah.
Don't ever get confused. Whatever sort of graph it is, like suppose it is xt graph, suppose it is vt graph, suppose it is ap graph. So if you have to find out area, the question is saying that what xt graph area will give us. So what you're supposed to do, you are simply supposed to multiply displacement with time. So it will give us meter second. Now, meter second is no such physical quantity, so they will not ask you. If If they ask you to find what is the area of velocity time graph, so just multiply velocity and time. So now try to figure it out. We learned velocity is nothing but displacement upon time. So displacement is going to be velocity into time. So we just got to know that from area of velocity time graph, you're supposed to get displacement. Similarly,
Right.
if it is acceleration time graph, what you have to do is just to multiply acceleration and time. So we already understood that rate of change of velocity will give us acceleration. So velocity is going to be acceleration into time. So from this velocity acceleration time graph's area, we'll get velocity.
All right.
Don't learn these things. Just try to understand that what exactly we are doing. Similarly, we are finding slope. Slope means you have to just divide whatever quantity on y-axis with whatever quantities they are on x-axis. Again, if it is xt graph, you have to find out slope. So just divide x by t, and we know x by t is nothing but it will give us velocity. The slope of xt graph will give us velocity. If it is velocity time graph, we have to find velocity over time, and we know velocity over time is nothing but acceleration. So slope of velocity time graph will give us acceleration. If it is an at graph, we'll divide acceleration by time. If we divide acceleration by time, we are supposed to get meters per second cube. Again, no such quantity exists. Or you can say, we don't have given any name to this quantity. So we'll simply say we'll get a quantity which has the unit meter per second cube. Similarly, in this case also, we don't have the name for this particular quantity, but we'll say that the area of xt graph will give us a quantity which has a unit meter second. That's it.
Okay,
Just
got
try
it.
to understand that what exactly we are doing. In slope, we are dividing y by x, whereas in area, we are multiplying y by y into x. That's it. So this is the
Can all
basic
be
difference
derived
between
from the
area and
same. It can all
yeah.
be derived from the same formula. No need to memorize.
Exactly. You don't need to remember anything. Just understand that what you are actually doing when you are finding area and what exactly you are doing when you are finding slope. You're simply
Got it.
dividing y quantity with x quantity, and in area you are simply multiplying x and y. That's it. So whatever type of graph is given to you, whatever it is asking, just do the same. You'll get whatever you want.
Got it.
Everything here in physics, we don't need to learn anything in physics. We only need to understand that what exactly is going on. If we understand it, how complicated the question becomes, we will be able to solve it because we understand the theory part. We understand the concept. And this is what we need to focus on every time.
Okay.
Is it clear?
Yeah.
All right, then let's keep it till here only.